Hey everyone, and welcome to another video on this channel. So today we're going to be going through 2026 A-level paper. So just a heads up, I know it looks different. This isn't fake. So the thing is, the paper was yesterday, and I've managed to collect all the questions. I put it into Claude, and I told it, can you format the paper so it's at least easy for me to go through. So don't worry, this isn't fake paper. I've checked with other people who've actually sat the exam. These are all the questions. Ignore the marks. The marks might, like shown here, might be a little different, but my answers are still going to be the same. I've heard some really awful things about this paper, like lots of people complaining. So I wanted to get this sent out as soon as possible so people could go through it with plenty of time before paper 2, so that they they can find out what you want to work on. So this is I'm still quite new to making these videos. So any kind of feedback, anything you want me to change or do better on, any questions you have, you can put a comment or you can send me an email, and I'm happy to respond privately or make those changes for future videos. But for now, let's just get straight into the paper. So it is going to be formatted a lot different than what you expect, but it's just so I could get this out as soon as possible. Okay, so let's start with question 1 here. It's asking us, so we've got the point -4,5 on this equation y equals f of x, and we have to find the coordinates of the point to which it's mapped after this transformation. So first here, we've got 4f of 2x. Okay, so f of 2x we know is a translation, and it's going to scale it by a half. So the x coordinate is going to be scaled by a half. I'm going to put scaled so you don't know, so it's not just a half. Okay, and I'm not sure I'm putting it there, sorry. Okay, and then we know that because there's a 4 on the outside, we know that the y is going to be multiplied by 4. It's going to be stretched by 4 times. Okay, so y coordinate is 4 scaled. So that means that after we put the point P in this function, we're going to get, so it's going to become -4 times a half, and then 5 times 4, which goes to -220. Okay, so that's part A. Now part B, y equals f of x plus 3 minus 2. Okay, again, so let's think about, what does f of x plus 3 mean? Let's isolate this box here. It essentially means that if we have the point -4,5, which we'll say is around here, we're going to shift it to the left by 3 coordinates, because f of x plus 3 means move your x coordinate to the left by 3. Okay, so that means that we would go from -4 to -4 minus 3. Okay, and now -2 here, it simply means we're going to move that point down by 2 coordinates on the y-axis. Okay, so we go 5 minus 2, so that takes us to -7, 3. Okay, so that would be your first 2 questions there, the first 2 parts of question 1. So let's move on to question 2 now. So we've got an equation here. I'm not sure why, but I always have a habit of just writing it out again. Okay, and we have to show that alpha lies within this interval of 1.1, 1.2. Okay, so the main way to do this is you just shift the function across. So for example here, sorry, not shift the function across, you would calculate the function at each endpoint of the interval. Okay, so let's calculate f of 1.1 here. I'm going to just write it down here so the examiner knows that I know what I'm doing. Sorry, I got a bit confused. I'm not sure I had to shift to the other side. I just meant sub it in. So let's sub that in now. So 1.1, I'm going to put that in my calculator. E to the 2 answer minus 1 plus 3 answer minus 7. So here we get roughly -0.379. Okay, and we're going to do exactly the same for 1.2. So we're going to get f of 1.2 is equal to, so on my calculator I've just stored as answers, so it's very easy for me to go back, and I get 0.6519. Okay, so clearly we can see here that there's a sign change. Okay, so the way I'm going to phrase it is, as there is a sign change, and the function is continuous, sorry, that says continuous, we can say that 1.1 is less than alpha is less than 1.2. Okay? So that's part A done. Now part B, so we've been told that, so we've got our iterative formula here, and we know x1, so we just need to find x2. So with these questions, it's actually quite important. Don't just put it straight into your calculator. It's best that you show you're working, in my opinion. So here, I would say x2 equals 1 plus ln 7 minus 3, 1.1, all over 2. So that gives you x2 equals, just bear with me 1 second, let's put that into my calculator. 1 plus ln 7 minus 3 answer over 2. So that gives me an answer of 1.15416 equals 1.1542 to 4 dp. And now to find the value of alpha, what's really good is if you use the answer function in your calculator, so I use a silver calculator, I don't have a scientific calculator, you can just keep spamming your equal sign over and over again. So if I write down, I'm going to write down the next couple. So x3 is 1.1317, x4 is equal to 1.1411, and if we keep just spamming that equals button, not x5, sorry, we're going to get that alpha converges to 1.138365 and so on, which is 1.1384 to 4 dp. 1.1384 to 4 dp. Yes. Okay, so that is question 2 fully done now. So that's another 5 marks knocked down. So let's move on to question 3. Okay, so we've got a curve here. Okay, so this should just be some simple differentiation, some bookwork differentiation. So I'm not really going to explain too much. All it is going to be is just taking the powers down and following the exact same rules that we've always learned. So 3x squared minus 4x plus 5. Okay, so now it's asking us to find the equation of the tangent to C at the point where x equals 2. Okay, so our first step here is to find the gradient. What is the gradient when the x coordinate is 2? Okay, so let's sub that in. Two squared minus 4(2) plus 5 equals 3 times 4, which is 12, minus 8 plus 5, and that should be equal to 9. Okay, so now we know our gradient is 9, and it's a tangent, not a normal. So y equals 9x plus c. Okay, when x equals 2, okay, let's just quickly find out what f of 2 is for this function here. So what is y when x equals 2? So 2 cubed minus 2 squared plus 5, 2 minus 7. So that gives you 8 minus 8 plus 10 minus 7. So y equals 3. So let's sub in now 2, 3 into this equation here. So 3 equals 9, 2 plus c. 3 equals 18 plus c. So c equals minus 15. So now we can say that y equals 9x minus 15. Okay, so I think that was a good question to another good question to start off the paper. So let's move on to question 4 now. Okay, so some domain and range function questions. Lots of people don't really like this topic. I think I did. I've some of my students that I teach as well. They're not really a fan of these topics. So state the range of f. Okay, well we can say that f is, so we've got 3x squared minus 2. Okay, let's think about, we can either think about this graphically, or we can, I'll explain it another way as well. If you think about it graphically, is it going to be a quadratic? Okay, and the lowest point of this quadratic is going to be when x is equal to 0. Okay, because you can either think about it, if we differentiate it, for example, this is just as to explain it, the turning point is going to be when x is equal to 0. Okay, so if we think about a quadratic, there's only one turning point, and this is a positive, so it's going to be right there. Okay, so that is the smallest possible value that quadratic will take. Okay, so that means that when x equals 0, that will be the smallest value we have. So what is f of 0? F of 0 is just minus 2. So therefore we know that every value of this function for any x in this domain is going to be greater than minus 2. So we can say that f of x is greater than or equal to minus 2. Okay, so now we've got a compound function question. So we've got g of f of 2. So our first step is to not get confused by this. We're first just going to find f of 2. So that's 3 of 2 squared minus 2. 3, 4 minus 2 equals 10. Okay, now we have to find g of f of 2, which is simply g of 10. And that is 5, 10 minus 1 over 10 minus 4 equals 49 over 6. Okay, so that's our g f of 2 and our g inverse, so the inverse function of g. Okay, so what we're going to do is, I'm going to say let y equals g of x. Okay, so y is equal to 5x minus 1 over x minus 4. Now what we're going to do is we're going to just try and solve for x. Okay, so it's going to be xy minus 4y. So I've just multiplied both sides by x minus 4. Now let us collect the like terms. So we're going to collect all the x's on the left-hand side. So that's going to become 4y minus 1. So x, y minus 5 equals 4y minus 1. So x equals 4y minus 1 over y minus 5. So the next thing here with inverse functions is pretty much just, following the same step every time pretty much. Okay, so what you can do here is you can just essentially, in your final answer, you can just swap essentially x and y. So we say for the inverse function, so now we can define x is going to be g minus 1 of x. And now we swap our y's for x's. Okay, so another method that some people do is they define y as g of minus 1 of x. Okay, and then from there, they essentially start off by working like this. And then they solve for y, essentially. So either method works, as long as you show that. But the last thing is we can't forget, we have to say for x not equal to 5. Okay, we have to remember our domain for the function. Okay, because we cannot allow x to be 5 because otherwise our function is therefore undefined. Okay, so hopefully that makes sense. So now let's move on to question 5 of this paper. Okay, so I don't actually have the graph because that's the thing with these papers. I didn't actually, because it was so quick, I didn't actually manage to get the graphs. So I'm going to do this question. If it does turn out that I need the graph, I'm going to stop with this. I'm going to do the question again when I can find it. But hopefully I can do this without it. Okay, so let's see what the question is saying. It travels on a vertical plane above horizontal ground. Starts its flight from the point on the ground, represented by O. Lands on the ground at the point represented by A. So the height at y meters for the helicopter above the ground has been plotted against the horizontal distance measured from O. So we've got parametric equations here. And we have to write down the maximum height of the helicopter above the ground. Okay, so the maximum height is, because we're thinking about y, that's the height. So we're trying to find out when is y maximized. Okay, so it's y equals 10 sine t squared over 4. Okay, so y equals 10 sine t squared over 4. And we know that the maximum value of our sine function is 1. Okay, so no matter what, we can't go above 1. So therefore, our maximum height the helicopter is 10 meters. So again, what I'm saying is, this thing says it's 3 marks. Don't rely on it for now, because I don't see this being 3 marks. So just focus on the answers for now. When I can get like a proper mark scheme, proper mark things, I'll try and get that out as soon as possible. But for now, this is what I'm working with. So now part B is saying, according to the model, the horizontal distance the helicopter has travelled from O when it is 5 meters above the ground for the second time. Okay. Okay, yeah, according to the maximum height. Okay, so have I missed something in the question? The horizontal. Okay, yeah. Okay, yeah. So when it's 5 meters above the ground, that is going to be when y is equal to 5. Okay, sorry, I got confused. So when y is equal to 5. So 10 sine t squared over 4 is equal to 5. So sine of t squared over 4 is equal to a half. Okay? So now we can say that we know the, we should know that sine inverse of a half. So I'm going to take the inverse here. We should know that occurs. I'm going to say it in, I'm going to say it in degrees first. That is going to be 30 degrees and then also 150 degrees. Okay? So that means we can say that t squared over 4 is equal to pi over 6, which is 30 degrees, or 5 pi over 6. I'm just going to draw this line and work across here. Okay? So then we can say that this is going to be the first time when it's 5 meters above the ground. And then that means that 5 pi over 6 is going to be the second time when it's 5 meters above the ground. So we're going to focus on the 5 pi over 6 solution. Okay? Because then we get t squared equals 20 pi over 6 equals 10 pi over 3. So t is equal to root 10 pi over 3. Now, if we're trying to find the horizontal distance, okay, that is going to be x is equal to 100 of root 10 pi over 3. Sorry, let me write that so it's a bit clearer. So x is equal to, I believe, I hope this is right, 100, so 2 roots 10 pi over 3. So I get roughly 179 equals, I'm going to do, I always use the 3SF because it doesn't really give me any, you know, specification for how I have to round it. So I'm going to say 180 meters to 3 significant figures. Okay, because that's the horizontal distance the second time. So it's important that we know we have 2 solutions. Okay, we're looking at the second one. Okay, so that is question 5 now done. So let's move on to question 6. Okay, so now we've got an integral here. So it's no bounds as well. So it should just be some calculations. So integral of 3 7x plus 1 with respect to x. Okay, so this is just going to be 3 ln the modulus of 7x plus 1 plus c. However, we have to remember that we have to take the derivative of what's in this, so the 7x plus 1. So the derivative of 7x plus 1 is just 7, and then we divide this by 7. Okay, so this is going to be your answer for part A. So just remember to divide by the derivative inside that bracket, so divide by 7. Now find in simplest form the exact value of the constant p for which this integral is equal to 6 over 7. Yeah, there's no way they didn't do that on purpose. But anyways, so between 2 and p, 3 over 7x plus 1 dx equals 6 over 7. By the way, important to know that p is greater than 2, just in case we get 2 solutions. So we know that the derivative of this is 3 over 7 ln 7x plus 1 between 2 and p is equal to 6 over 7, right? So let's do this now. So 3 over 7 ln 7p plus 1. By the way, I'm taking the modulus out because we know that p is positive, so it won't really impact how I work with that. Minus 3 over 7 ln of 15 is equal to 6 over 7. I'm just going to multiply by the 7 to make this working out cleaner. So we get 3 ln 7p plus 1 minus 3 ln of 15 equals 6. Now in hindsight, I probably should have divided by 3. I'll just do that now quickly. Minus ln 15 equals 2. Okay, so I'm going to use the law of logs here. So I can write this as 1 logarithm 15 is equal to 2. Okay, now if I raise this to the power of e, so if I do e to the power of both sides, so I'm going to get 7p plus 1 over 15 equals e squared. Because if I do e to the power of ln, 7p plus 1 over 15, it just becomes whatever the ln is, because it's the ln is the inverse function of your e. Okay, so it just becomes 7p plus 1 over 15. Now, all we have to do is just solve for p. So we get 7p plus 1 equals 15e squared. 7p equals 15e squared minus 1 over 7. Let me get rid of that 7 here. 15e squared minus 1 over 7. That should be your final answer for part B. So question 6 done already. We're working through this quite well. So I'm just going to take a quick break and then we can continue with question 7. Okay, sorry for the cut. I just had to find this diagram and paste it here. Sorry, I'm going to have to go back and forth between the two questions, between the two pages. So we've got the information that, so we've got the semicircle here, and we know that R1 is double R2. Okay. And I had already labeled this before, sorry. R and R. So we can work with this because it wants us to find a function of theta and pi. So I'm going to label this here pi minus theta. And let's start by finding out the area of R1. So this is just going to be the area of the sector minus the area of the triangle. Okay, so the area of the sector is half r squared theta. Okay, now we're going to minus half r squared sine theta. So for anyone who wondering how I got that, this is from using the formula half times a times b times sine c for the area of a triangle. Okay, so using that formula, and this one I believe is provided in the textbook. If not, the way I derive it is because the sector area is theta over 2 pi times pi r squared, which gives you theta over 2 times r squared, which is exactly the same as that. Okay, so that's our area of R1. Let's quickly do the same for R2. So the sector area of R2 is going to be half r squared pi minus theta. Okay, but minus exactly the same thing now. Minus the area of that triangle. Actually, not the exact same now. Minus a half r squared sine pi minus theta. So not the exact same. Okay, so now what we're going to do is we're going to sub this into the equation. R1 equals 2R2. Might be a bit tight for space, but hopefully I'll make do. So half r squared theta minus half r squared sine theta equals half r squared pi minus theta minus half r squared sine pi minus theta. Okay, so, oh, sorry, I forgot the 2 here. What I'm going to do here is I'm going to get rid of the r squareds. Actually, I'm going to get rid of the r squareds and I'm going to get rid of the halves. So it's going to become theta minus sine theta equals 2 pi minus theta minus sine pi minus theta. Okay, so I might have to go below here. So sorry if that, or to be honest, I can just shift this across because, whoops, I can just shift this across. It's easier to follow. Might make it a bit smaller as well. Sorry, I just want it to be easier for people to go through. So I'm just going to work on this side here. So I'm going to follow from the last line on the left side. So theta minus sine theta is now 2 pi minus 2 theta. Now we're going to use the double. Oh man, this isn't going to fit. Okay, bear with me 1 second. Let's just go like this. Hopefully now this fits. Yeah, that should fit now. Okay, so I'm going to follow on from the bottom line there. So theta minus sine theta equals 2 pi minus 2 theta minus, let's use the formula now, sine pi cos theta minus sine theta cos pi. Okay? So now, that should give us theta minus sine theta equals 2 pi minus 2 theta. So sine theta is just going to be equal to 0. So it's going to be plus sine theta cos pi. Okay? And cos pi is equal to minus 1. So you get theta minus sine theta equals 2 pi minus 2 theta minus sine theta. So now let's rearrange. Okay? Hold up 1 second. That doesn't look very good. That doesn't look. Oh, did I make a mistake here somewhere? Ah, yeah, I've spotted it. So this is a very silly mistake. So don't do this. So when I was multiplying out here, I actually forgot to put a 2 here when I was going from this step to this step. So I'm sure people watching would have noticed that as well. So just going to go ahead and fix that. So this should have a 2 in front of it. So therefore, this should be plus 2. And therefore, this should be minus 2. Which is better now. Okay? Because now I'm going to shift everything to the left-hand side. So this is going to give me theta, so minus sine theta plus 2 sine theta equals 2 theta. So now I'm going to get 3, okay, it wants it, so sine theta plus 3 theta minus 2 pi equals 0. So we can see here P is 1, Q is equal to 3. Sorry about the spacing and sorry about the silly mistake, but that is how you show that equation. Okay, now let's go on to part B, to the Newton-Raphson method. So the formula for this, I'm just going to write it down, is xn plus 1. I know we don't have x's, it's just for my own understanding, over f dash of x of n. Okay, so let's first of all, so we have our function in terms of theta, so let's find the derivative of this now. So we have f of theta is that, so f dash of theta. So all I'm going to do now is I'm going to take the derivative of this function here with respect to theta. So that's going to give me cos theta plus 3. Okay, now what we can do is we can write out our formula. So theta n plus 1 equals theta n minus, so this is going to be the numerator, not the denominator, is going to be this divided by cos, okay, hopefully this is okay to read. I'm going to put the plus over here. Okay, so now what we're going to do is we're going to substitute in 1.3. So to find theta 2, we're going to put 1.3 minus sine 1.3 plus 3, 1.3 minus 2 pi over cos 1.3 plus 3. So let me sub that into my calculator. Just remember that you're in radians. So we should get sine 1.3 plus 3, 1.3 minus 2 pi over cos 1.3 plus 3. So that should roughly give you theta 2 equals 1.73446 equals 1.734 to 3 dp, I believe. I'm pretty sure that is right. Okay. And so the question only asks for one step. It only asks us to get to theta for the second approximation. So that would be it for question, what is that? Question 7. Okay. So hopefully that makes sense. Let's move on to question 8 now. So it's asking us to express this as an integral. Okay. So this is just something that you should know. So we can write this as an integral. So the bottom part of the sum becomes the bottom bound. The top part of the sum becomes the top bound. And this just becomes what we're integrating. X e to the 2x with respect to dx. Okay, that's just something that you're expected to know. Okay, so now let's look. Okay, so now it actually wants us to find the exact value of this answer. So 0, 3, x e to the 2x with respect to dx. Okay, So there's a couple of ways we can do this, but I think the best way to do this is probably with the product rule. Actually, I think that might be the only way. Anyways, I'm going to do a product rule. Sorry, integrating by parts. I'm not sure I said product rule. So I'm going to let u equal x, dv by dx equals e to the 2x. So that gives us du by dx equals 1, and v equals half e to the 2x. Okay, so let's write this out now. So we're going to do uv, so half x e to the 2x, and integrate that between 0 and 3. And now we're going to subtract half e to the 2x with respect to dx. Okay, so I am going to simplify the left-hand side now so I can kind of mix it in with the rest of my working. So that becomes 3 over 2 e to the 6 minus 0, which is good because we have the 0 there, minus the integral of this is 1 over 4 e to the 2x between 0 and 3. So we get 3 over 2 e to the 6 minus 1 over 4 e to the 6. Oh, let's not forget this, minus 1 over 4. 3 over 2 e to the 6 minus 1 over 4 e to the 6 plus 1 over 4. Now I can simplify that in my head, so we get, that becomes 5 over 4 e to the 6 plus 1 over 4. Now, one thing that I usually do to check this is I can literally just put this integral in my calculator. So the integral of 0 to 3 x e to the 2x. Okay, so where's that? I've lost it. E to the 2x. So this gives me roughly 504.5359. Okay, I'm just going to keep that in my head. Now I'm going to write down this exact thing here. 5 over 4 e to the 6 plus 1 over 4. And I can see by going up and down on my calculator, I get the exact same thing. So I know that my answer must be right. Okay, so that is question 8 done. Now let's move on to question 9. Okay, so here we've got to show that. So I know a lot of people don't really like these show that questions. So hopefully I can explain this really well. And a lot of these questions, so the show that's with trigonometry, it's a lot of practice. So this comes with doing lots and lots of questions. And yeah, you kind of just get the hang of it at some point. So let's start with expanding this. I think that is the best way to go about this. Yeah, I'm going to expand this. So I'm going to write cos theta, cosec theta, minus cos theta, sec theta, plus sine theta, cosec theta, minus sine theta, sec theta. To be fair, I probably should have written the expression out above. So I'm going to do that because, you know, I'm a math student. That's pretty poor if I don't write that out. Cos theta plus sine theta, cosec theta, minus sec theta. Okay, now I can say that is equal to this. Okay, so now let's write this out. So we know cosec theta is 1 over sine theta. Okay, so cos theta over sine theta minus cos theta over cos theta plus sine theta over sine theta minus sine theta over cos theta. Okay, so we know that these are just going to cancel out because this is going to become minus 1 plus 1. So we're left with cosine theta over sine theta minus sine theta over cosine theta. Okay, so now let's make this into one big fraction. So I'm going to multiply the left one by cos over cos. So we're left with cos squared theta. I'm going to multiply the right hand side. So let me fix this. By sine over sine. So we get minus sine squared theta. And that's going to be divided by sine theta, cos theta. Okay. So now what I can do is I can say, well, the top function, we know that's the identity for cos 2 theta. Okay. And the bottom identity, we can say that is half of sine 2 theta, because sine 2 theta is 2 sine theta cos theta. So sine theta cos theta is half of sine 2 theta. Now you can see here, I've got 2 cos 2 theta over sine 2 theta. That is equal to 2 cot 2 theta. So here we have k is equal to 2. Okay. So hopefully that makes sense. Sorry, the working is going to be a bit squished. I hope it is still readable because, you know, the Claude, you know, it didn't give me enough working out space. So I'm going to try my best with this. Okay. Now let's move on to part B. So first of all, just going to make a box of this so I don't forget this. Okay. Solve this equation. All right. So my first thing is this is exactly what they've given us. So we can write this. So using part A, we can literally write that bracket as 5. So remember here, this 5 wasn't in the original one. 5 of 2 cot 2x equals 4 cosec squared 2x. Okay? And we can say that this is going to become 10 cot 2x equals, now I'm going to use the identity here. Okay? I'm going to say this is equal to 4, 1 plus cot squared 2x. Okay? So that's an identity that you should know. So now what we're going to do is we're going to rearrange this and we're going to get a quadratic. So we're going to end up with 10 cot 2x equals 4 plus 4 cot squared 2x. So 4 cot squared 2x minus 10 cot 2x plus 4 is equal to 0. So I am just going to divide by 2 here because it's just going to be easier to work with. Plus 2 equals to 0. Now this is factorizable. Okay, so 2 cot 2x, just cot 2x here. So we're going to get minus 2 minus 1 is equal to 0. Okay, this is good. So I've got some blank space here. So what we can say from this is cot 2x is equal to a half, or cot 2x is equal to 2. Okay, now it's important here that we look at the fact that we have 2x and our domain was given for simply x. Okay, so what I do in these questions is I adjust my domain. Okay, so I see that we've been given that x has to be between minus 90 and 90. So if I'm solving for 2x, well, I know that 2x is going to be between minus 180 and 180. Okay, so now I can say, okay, so cot 2x is a half. So 2x, okay, is going to be the tan inverse of 2. Okay, because remember, cot is 1 over tan. So if I write it out just so people understand what I've done here. So I'm going to multiply by 2 tan 2x. So I get tan 2x equals 2. So 2x is the tan inverse of 2. So now I'm going to write down all of my solutions that are between minus 180 and 180. Okay, so 2x equals, let me go back into degrees here. So set up, so tan inverse of 2. So my first solution, okay, I get is 63.4349. So what I always do is I always like to store my principal solution, so my first one. Okay, now I know, but I'm between minus 180 and 180. I can't do 180 plus here because that's going to take me outside of my bound. So what I'm going to do is I'm going to subtract 180 from this answer. Okay, so that gives me minus 116.5650512. So those are my two solutions for the left-hand side. Okay, now let me do the same thing for the right-hand side. Okay, so again, using the same thing, 1 over tan 2x is equal to 2. So tan 2x is equal to a half. Okay, so that means that 2x is tan inverse of a half. So my possible values for that are, well, my first one is 26.565 and so on. So I'm going to store that one to B. So just as my own note, that's stored to A, that's stored to B. Okay, now we can do, again, we'll subtract 180 because we can't add 180 here. So we get minus 153.4349. Okay, So remember that tan repeats every 180, but given our bounds, we can't add because it's going to go outside of our bound, outside the domain we're allowed to use. So we have to subtract. Okay, so now we're done. We have our solutions. Okay, there's nothing we've missed. So all we have to do now is divide our solutions by 2. Okay, so that gives our possible values of x. So I'm going to start from the very smallest. So divide this one by 2. I think did it give to 1 decimal place? So minus 76.7 degrees. Next one is a minus 180 divided by 2. So minus 58.3 degrees. Okay. The next one is b divided by 2, which is 13.3 degrees. And last of all, a divided by 2, which is 31.7 degrees. All to 1 dp. Okay. So a little bit more complicated question. Question 9 done. So pretty hefty. So some solutions to find there. Just having to spot, the quadratic and all of that, and just remembering to find all of your solutions by doing the 180 degrees from subtraction. Okay. So just going to take a quick break, and then we'll continue from question 10. Okay. So back from the break. So before we actually continue with question 10, there's a couple of things I wanted to go over. So my friend actually just sent me the full paper now. So I have got the full proper Edexcel formatted paper, but because I'm so far into the paper, I thought there's not much of a point of restarting it purely for the formatting. What I can do is I can quickly go back and show you the diagram, the accurate diagrams for these questions. So I believe it starts off around, so here. This is the diagram for the model helicopter. So we can see the height, the horizontal height and the vertical height. To me, I mean, I solved the question without even really using it. But yeah, just so that you know, that's the diagram. Then the next missing one was question 7. So I did show a diagram, but it actually wasn't purely accurate. So I had used the one at the top here. It doesn't really change how the question is done, but for those who are wanting to actually know what the actual diagram actual diagram is, it is the one at the bottom. So what I'll do is I'll just get rid of this one. How do you do this? Okay, well, that's not really what I wanted to do. So it is the one at the bottom. So if you just if I can just delete this one and shift this one back up here and get rid of these annotations because we've already gone through that. This is the accurate diagram, pretty much the exact same thing. And now we can continue to question 10. So let's start with this. So we've clearly got this curve here. So what I've done again is I've pasted it at the bottom. So this is the accurate diagram now again. So we've got a curve C given by this equation here, and we have a point P that has x coordinate 2. Okay, and the line is the normal to C at this point. So I'm going to label this straight away as 2 because I feel like this is going to help later on. So that's x equals 2, and that's the normal to C at the point P. So use calculus to find an equation for L. Okay, so what we're going to do now is we're just going to do some differentiation. I was about to say derivation, some differentiation. Okay, so let's first write this out in a bit of a way that's easier to work with, like this. Okay, so now let's take the derivative of this. We're going to use quotient rule. Okay, so for those who might have forgotten it, if we have u over v, okay, we're going to be doing v du by dx minus u dv by dx all over v squared. Okay, let's write that out now. So v here is just 3x squared plus 4 to the half. And if you multiply that by du by dx, that will be 7. Okay, and now minus u dv by dx, so minus 7x. So what's the derivative of this? Well, it will be a half 3x squared plus 4 to the minus a half. Okay, so we're doing the normal power rule, but let's not forget to multiply by our 6x. Okay, because we're going to take the derivative of 3x squared, which is 6x. Okay, all over v squared, all over 3x squared plus 4. Okay, so dy by dx equals 7. I hope I don't run out of space here as well. Minus 7x, 3x. Okay, so what I'm going to do is I'm just going to combine it here so I don't run out of space. So minus 21x squared, 3x squared plus 4 to the minus a half over 3x squared plus 4. Okay. So what we can do here is we can, I think straight away we can just try and find our answer by subbing in x equals 2. Okay. How many marks is this? I mean, to be fair, we could kind of try and simplify this as well. So if we multiply the top and the bottom by 3x squared plus 4 to the half, okay, we will get, this will just become 3x squared plus 4. This will become minus 21x squared because the powers will add to 0 and anything to the power is 1, power of 0 is 1. And then over, or 3x squared plus 4 multiplied by 3x squared plus 4 to the power of a half will just be 3x squared plus 4 to the power of 3 over 2. So all I've done here is I've multiplied the top and the bottom by a 3x squared plus 4 to the power of a half. Okay, now all I'm going to do is, well, by the way, this can be written as 28 over 3x squared plus 4 to the 3 over 2. Okay, so just do some simplification there. Let's find a gradient at x equals 2. Okay, so when x equals 2, dy by dx equals, well, it's going to be, well, this is a pretty horrible number, I think. Maybe I'm wrong. Okay, no, I'm wrong. So it'll be 28 over 16 to the power of 3 over 2, which is 7 over 16. That's not so bad. Okay, so I'm trying to figure out how can I do this with space, the space that I've been given. Okay, so I might actually have to do, this time I might have to work below this curve here because I can insert pages. So what I'm going to do is I'm going to shift all the working down so you can follow it all at once. So just bear with me one sec. I'm going to insert a page here. Okay, so I put a page between this. So for now, I will keep all the working down here, and then we'll see how I can fix that later. Okay, so we're still continuing on question part A. I'm going to label it this time. Part A. Okay, so we've now got a gradient at x equals 2. Okay, so we're trying to find the normal. Okay, so for the normal, we need the negative reciprocal. Okay, negative oh dear. Okay, I hope that's right. I mean, my English has always sucked, so you can just violate me for my spelling if that's wrong. So for L, M equals minus 16 over 7. Okay. And now what we're going to do is we're going to use the formula here. Y minus y1 equals m, x minus x1. So if you haven't seen this formula, it's literally the same as the gradient formula. Okay. But we just fix y and we fix x. Okay. We could also do it just doing y equals mx plus c and subbing in points. I'm just doing it this method. So one thing that we haven't done yet, actually, let me get rid of this, is we haven't found out what the function is equal to at x equals 2. So let's write that down. So at x equals 2, y is equal to 7 answer over 3 answer squared plus 4 to the power of a half. 7 over 2. Okay, so y minus y1 equals m x minus x1. So y minus 7 over 2 equals minus 16 over 7 x minus 2. So I'm going to multiply by 7 here. 7y minus 49 over 2 equals minus 16x plus 32. Okay, now I'm going to multiply again by 2 because I think it wants it, they're integers. So we have to multiply by 2 again to get 14y minus 49 equals minus 32x plus 64. So 32x plus 14y minus 113. equals 0. I think that's exactly how I wanted it. Yes, it is. So I'm going to keep this here for now, actually. And I'm just going to work on B and C. I think I should have enough space for C. I definitely don't have enough space. So what I'll do is I'll work on that. I'll make another page to work on that. Okay, so that was part A. Part B, actually, let me just insert pages so I'm not going here and there. Okay, let's do part B now. So part B is saying the line intersects y-axis of the point Q, write down the exact y coordinate of Q. So that's just simply x is equal to 0. Okay, so x is equal to 0, 14y equals 113, y equals 113 over 4. So it's write down the exact y coordinate of Q. Is that it? Yeah, it's the y-intercept. Yeah, so just setting x equals to 0. And now let's find out part C. So now we have to do some integration using the figure that they gave us. Okay, so let's work on that. So what I'm going to do is I'm going to shift this up now here so we can work on part C. So I'm going to do some annotations on the diagram so it can help me. So we know this point here is 2. Okay, I could have sworn I labeled that earlier. Yeah, that's where it went. That point there is 2. We also now know this point to be 113 over 4. Okay, so what I'm seeing now is, sorry, this isn't 113 over 4. This is 113 over 4. Okay, if we find this point here, we've got a triangle. Then we can subtract this kind of curved shape here, and we'll get our area R. So I think my first point here is, let's find out what that x point is. So if we set y is equal to 0, 32x equals 113. So x equals 113 over 32. Okay, so the area of the whole triangle is half times base times height. Okay, which is, I don't know 113 squared off the top of my head, unfortunately. So gonna have to check that out. Oh my god, that is a massive number. Okay. That's kind of starting to get me to, I'm kind of doubting the whole kind of question now. And I just figured out why. That's quite funny. This should be 113 over 14. I don't know how okay, let's fix that. There we go. I'm sure you guys were probably mentioning that as well. Okay, now it's not too bad. I mean, it just looks bad, but it's not actually bad. Okay, so that's the area of our whole triangle there. So OQ, and then we'll just whatever that point is, we don't really have to label that. So let's work on our integration now, actually. So what I'm going to do here is I'm going to integrate curve C from 0 to 2. Because what that is going to give me is that's going to give me this area here. All right, and then we can work on finding the triangle. Okay, so let's work on that. So integrate from 0 to 2. So let's unlock that. So from 0 to 2 of the curve, which is, where is that? Okay, yeah. So integrate the curve from so 7x over 3x squared plus 4 to the half. So root 3x squared plus 4. So how can we do this easily? Let's see. Okay, yeah. No, I'm seeing a way we can do some reverse chain rule here. So if we just try to integrate, so if we just try to differentiate 3x squared plus 4 to the half, we're going to get a half 3x squared plus 4 to the minus a half times by 6x. So we're going to get 3x squared plus 4 to the minus a half, right? So we're going to get 3x over root 3x squared plus 4. But we clearly want 7x. So what we can do what we can do to fix this is we can multiply this original function by 7 over 3. Okay? Because if we multiply this by 7 over 3, okay, so then we times this by 7 over 3, and then we times this by 7 over 3, well, look at that, we get exactly what we want. Well, I'm just going to put dot, dot, dot. So that's how we can use the reverse chain rule there. Okay, if you spot that, that's a very easy way to integrate it, because I'm not sure how else you would do that, to be honest. But that's the way that I'm seeing it. Okay, so hopefully that makes sense. Okay, so now we can immediately rewrite that as 7 over 3, 3x squared plus 4 to the power of a half between 0 and 2. Okay, so let's write that down. So that's 7 over 3. So that's going to be 16 to the power of a half minus 7 over 3, 4 to the half. So that's 7 over 3. So 16, root 16 is 4. So 28 over 3. And root 4 is 2. So 14 over 3. So that gives me 14 over 3. Okay, so keep in mind, that's this area here. Now let's work on this triangle. So that shouldn't be too bad, because we know because we know what P is actually. We know P is when x is equal to 2. So let's just find out. I'm not sure if we did that before actually. Did we find out? Yeah, we did actually. At x equals 2, y is 7 over 2. So let me again label that here. All right, so I can find the area of that green triangle by doing triangle half times base times height equals half times the base here is going to be, I'm just going to double check it because I don't want to make I don't want to make a mistake here. So 49 over 32 times 7 over 2. Okay, so half times answer times 7 over 2. That gives us 343 over 128. Okay, so hopefully the moment of truth now, we're going to do our whole triangle, which is 12769 over 896 minus 343 over 128 plus 14 over 3. Now, if this doesn't work, 12769 over 896 minus 343 over 128 plus 14 over 3. And that gives us our answer of 145 over 21. So I think that's a good method for this. I mean, I'm sure maybe someone will find a way that I could have done that quicker, but hopefully at least that does make sense, what I've done there. Let's see. I'm sorry again about the formatting and everything. If I had space, I would have done it all there, but I just decided to do it all on separate lines there. So hopefully that makes sense. So let's move to question 11 now, getting closer to the end. So question 11. Okay, so express this in the form r cos. So this is something, I think the name is like harmonic something. Okay, so in radians, of course, because we've got the bound between 0 and pi over 2. Okay, so the way I do this is, so, everyone has a different method. I just like to write it out. So r cos x plus alpha equals 4 cos x minus 13 sine x. So we can say r cos x cos alpha minus r sine x sine alpha is equal to 4 cos x minus 13 sine x. Okay. So for the first thing that we can do is we can kind of do an identity here. So we can say that it's kind of like a comparing coefficients. So we can say here, well, if we compare this one to this one, if they're equal to each other, it must mean that r cos alpha is equal to 4. Okay, because then that means that it's 4 cos x. And the same, if we compare this one with this one, we want our r sine alpha to be equal to 13. Okay, so just doing some comparing coefficients. Now we can do two things with this to find both r and alpha. Okay, first thing we're going to do is we're going to do 2 divided by 1. So that gives us tan alpha equals 13 over 4. So therefore alpha is equal to, let me remember to switch into radians. So tan inverse 13 over 4 is 1.2722. So to 3dp, 1.272 radians to 3dp. And lastly, we can do 1 squared plus 2 squared, okay? Because then that gives us r squared cos squared alpha plus r squared sine squared alpha is equal to 4 squared plus 13 squared. So therefore r equals root 4 squared plus 13 squared, and that should be root 185. Okay, sorry again, it's getting a bit cramped, so what I'm going to do is I'm just going to shift this all to the left here so I can write my final answer. I'm just going to shrink it a bit. So if you do need anything, hopefully it's still visible. So I can write my final answer. So I would write root 185 cos x plus 1.272. So that will be my final answer for that question. Okay. So part B, so now we're just going to have to model it. So we're going to have to use what we've just done in this question here pretty much. Okay. So the demand for electricity in the UK on a particular day is given by the equation here. So we've got our bound here. I'm just going to remember to box that just in case. Use the equation and the model of part A to answer part B and C. So deduce the minimum demand for electricity during this day. Okay, so the first thing I'm going to do is I'm going to write it in the form of model A. So D equals 30 plus, so notice how we had used cos x, okay? But now they're doing cos pi t over 12 plus 2, 0.2. So that means that now it becomes, so plus root 185 cos pi t over 12 plus 1.472. Okay? Actually, wait 1 second. Plus 0.2. Yeah, I believe that's fine. Okay, so now if we want to find the minimum, okay, well, the minimum is going to occur when we think about cos's minimum. What is the minimum of the cosine function? Well, the minimum of the cosine function is -1. So the smallest time this is going to occur when pi t over 12 plus 1.472 is equal to -1. So therefore, d min is equal to 30 minus root 185, which is 16.398 equals 16.4 gigawatts to 3 SF. Okay, now let's work on part II. Okay, I'm just going to shrink this. I'm going to shift it to the side. Actually, that's going to be a bit of a problem, isn't it? Okay, yeah, I'm just going to insert a page again. Sorry if this is getting confusing. Hopefully it's still easy to follow. Not much I can do, I'm afraid. Okay, yeah, I think this should still be easy to follow. So I'm just going to label it here so everyone knows. Part BII. Okay, find the time of the day when this minimum demand occurs. Okay, so if we're trying to find the time of the day when the minimum occurs, it's just going to be, as we've set, cos pi t over 12 plus 1.472 is equal to -1. We're trying to figure out when is it equal to -1. Okay, so now we can say, well, if t is, okay, so we're going to find the inverse now. So pi t over 12 plus 1.472. Well, cos of -1 occurs at pi. Okay, so the cos inverse of -1 equals pi. I'm not sure what I've done there, to be honest. Yeah, equals pi. Okay, so now what we can do is we can say, well, pi t over 12 plus 1.472, oh, sorry, equals pi. minus 1.472. So t equals 12 pi minus 1.472 over pi. So that should give us our answer of 12. So 12 pi minus 1.472 over pi. 6 point, I think this is 6.377 and so on. Yeah, so 6.377, but it says find the time of day. Okay, so it's taking this roughly this many hours. Okay, so we times it by 60, we can see that's roughly 382 minutes. I have no idea why I did that. So that's roughly 6 minutes and 6 hours and 22.6 minutes. Okay, so roughly 6 hours and 22.6 minutes. Okay, occurs. So I'm going to round that. So I'm going to say that it occurs because it's t hours after what? T hours after midnight. So I can say that occurs at 6:23 a.m. I think that's fair. And so I'll just let them know. So I've done it to the nearest minute there. Okay. So that's part BII. So I'm going to continue with C down this way as well. And hopefully it just leaves me with a just perfect space to do D. So at 3 p.m. on this day, the demand for electricity is increasing at a rate of K gigawatts per hour. Whoops, let's get rid of that. Find the value of the constant K, giving this answer to 3 significant figures. Okay, so this is just going to have to be some differentiation here. So I'm going to rewrite the function so it's easier to follow. So D equals 30 plus root 185 cos pi t over 12 plus 1.472. Okay, let's differentiate this with respect to t. So that's going to give us root 185 negative root 185 sine pi t over 12 plus 1.472, but again, I'm going to multiply that by pi over 12. Okay, so now we have to find it at the time when I believe it's, so if it's at 3 p.m., that means since midnight there's been 15 hours. So when t is equal to 15, dd by dt, okay, let's just hope that I don't write this into my calculator wrong. Sine, so 15 pi over 12 plus 1.472 multiplied by pi over 12. That gives me 2.75398 equals 2.75. Does it say anything? Okay, it says K gigawatts. So I don't have to write the what's it called? The units. So I can say K equals 2.75 to 3s. Hopefully that makes sense. All we had to do there was just take the derivative of our function and set t equals equal to 15 because it's at 3 p.m. So it's been 15 hours since midnight. Okay, part D, so I'll just do that down here now. So give a reason why it would not be sensible to use the same equation to model the demand for electricity in the UK of every day of the year. Okay, so what this is saying is, if we look at this function is looking at as like a single fixed model. Okay, so if we just look at, where have I written it down? Yeah, if we just look at this one for a sec. Okay, this has got like a fixed model. It's assuming that we've got like the same demand pretty much all the time. Okay, so we have to actually think about it. Is electricity just going to be sitting like, is the demand for electricity just going to be like that? Okay, well, it's not just going to be a periodic demand. Okay, demand varies, for example, with lots of different factors. So we can say that no, it isn't sensible to use the same equation as electricity demand isn't periodic, so it doesn't follow like the same pattern like all the time, and may depend on factors like the season. So this is quite long, but I always, just make sure just to get that extra mark. So again, sorry about the formatting. I hope all of this work so far has made sense. And let's go on to question 12 now. Okay, so question 12, let's see what we've got here. So we've got a sketch a graph of y equals px minus q. And it's a modulus function here. Okay, so let me just do my axes myself. I'm guessing they would have given you axes to draw on, but well, it's not a problem. X, y. Okay, so let's think about this function. We've got y equals the modulus of px minus q. Okay, let's think about this. All right, when is y going to be equal to 0? Okay, there's only one point where y is equal to 0, and that is when px minus q is equal to 0. And that's when px equals q, so x equals q over p. So at x equals q over p, we have a y coordinate of 0. So they haven't given us any information, but we know that p and q are positive. So we know that q over p is going to be around here somewhere. So honestly, we can pick any random point and just label that as q over p. Okay, so that would be our q over p. Now it's saying, now we have, no, it's not saying anything. Our last thing is, we can find the y-intercept. So when x is equal to 0, what is our y value going to be? So we just set x equals 0 here, we're going to get y equals the modulus of minus q. So that means that y is simply q. So as q is again positive, you can say q is here. So all we have to do now is we just have to essentially join up. I'm going to try and do this accurately. Okay, well, I'm going to adjust this now. So I'm going to say that this is now q. Okay, and all we have to do is do the exact same the other side. Okay, so we're just going to do the same gradient on the other side. No, that's not what I meant to do. Just assume that is the same on that side. Okay, and that would be your answer for the modulus. Okay, because remember, modulus functions always have this kind of like V shape here, like this. Okay, so when I said the exact same gradient, I didn't mean it. I meant the absolute value of the gradient will be the same, but this will just be the this is the negative version of this one. That's what I meant to say. Okay, so one is the negative of the other. So we've been given a curve of equation y equals k over x. Okay, so it's a reciprocal, and it's telling us that it's going to intersect this modulus graph, okay, 3 times. Okay, and it's telling us to find in terms of p and q the range of values of k. Okay, so there's a couple of things. So it's first of all important to know, what does the reciprocal graph look like? Okay, so if we have a positive, so if we have k over x, so y equals k over x, okay, as k is positive, it means that all of our intersections, okay, so it's going to look like this, and it's going to look like this, roughly. So that's just a rough understanding of what it would look like. Clearly, there's not going to be any intersection in this bottom left quadrant. So what I'm going to do is I'm just going to completely ignore it. Okay, well, I forgot that it's my own drawing. Completely ignore it. Okay, let's look at the top right one. We're clearly only going to have, what I can see is we're only going to have one intersection on that on this positive gradient part. Okay, because it's not really possible for there to be 2 intersections there. Okay, and we have 2 intersections on the negative part of the curve. Okay, so what we're going to do is we're going to isolate it. We're just going to look at this negative part here. So what we're going to do is we're going to look at y equals minus px minus q, only looking at that negative part of the curve of the modulus function. Okay, so let's set them equal to each other. So minus px squared plus qx equals k. So now what we have is, actually, we have a quadratic. Okay, and what did we say? We said if we have one, if we have one intersection here, if there's exactly 3 distinct intersection points, that means that we're supposed to have 2. So we're supposed to have 2 intersections here. Okay, sorry about that notification. So we're going to have 2 intersections in this negative part. Okay, so what does that mean for our discriminant? Well, our discriminant should be therefore positive. I think I have enough space here. So b squared minus 4ac should be greater than 0. So q squared minus 4pk should be positive. So q squared should be greater than 4pk. So k, let me go on to the next slide, should be less than q squared over 4p. Okay? Now, let's not forget, k is a positive constant. Okay? So k has to be positive and has to be less than 4p. And the reason it can't be zero is because if it was, there would only be one intersection point when y is equal to 0. Okay? So hopefully that makes sense as to hopefully the visualization as well. So this looking at this single reciprocal graph. Okay, so it's important to know that all the intersections must happen in the positive x quadrant. So only in this quadrant do the intersections happen. Okay, and because of the way that it curves, because of the slope, it always intersects. It only intersects the positive one once. So that's how we know we have to use the discriminant and look for two solutions in the negative slope. Okay, so hopefully that makes sense. I believe, yeah, that was it for part B. So let's move on to question 13 now. Okay, so we've got a bit of a geometric sequence here. So it's given us the third, fourth, and fifth terms, which is, I guess, a bit strange. And we've got the fact that it's between 0 and pi over 2, and find the exact value of the common ratio of the sequence. Okay, so common ratios are always going to be the same between two values. So the ratio to get from sine theta to 2 cos theta, root 2 cos theta, is going to be the same as this one. So what can we do? Well, we can say that r equals root 2. Let me need to be conscious of space. I keep losing space. Is equal to root 2 cos theta over sine theta. However, r is also equal to root 3 cot theta over root 2 cos theta. Okay, so we can say that they're equal to each other. So root 2 cos theta over sine theta is equal to root 3 cot theta over root 2 cosine theta. Okay, so cos theta over sine theta is the same as cot theta. So we can say root 2 cot theta equals root 3 cot theta over root 2 cos theta. Okay, so now what we can say is that if we multiply it across, so we can get rid of the cot thetas here. So we can say root 2 equals root 3 over root 2 cos theta. Okay, so then we can say, let's multiply by root 2. So we get 2 equals root 3 over cosine theta. So therefore, cosine theta is equal to root 3 over 2. Now we should know that this occurs when theta equals to pi over 6. Okay, so if theta is equal to pi over 6, well, we can just sub that back into our equation to say, well, root 2 cos pi over 6 over sine pi over 6. So r is equal to, let's find it, root 2 cos, I should be doing this in my head, but we'll just, root 2, okay, well, I've written that wrong, cos pi over 6 over sine pi over 6, and yeah, so that you get root 6 as your common ratio of the sequence. Okay, let's go on to part B now. So it's asking us to find the exact value of the sum of the first 3 terms of the sequence. Okay, so if we think about it, let's write it out. So our first term's a, multiply by our ratio, so we get sine theta. Okay, so sine theta is ar cubed. Okay, so what does that make? If we want to find a, well, it's just a over sine theta. Hang on a second. Almost made a mistake here. Okay, this is actually sine theta because it says the third term. So ar squared. So sine theta equals ar squared. So a equals sine theta over r squared. Well, what is r? R is root 6. So that means that sine a is sine theta over 6. Okay, so now what we can do is we can write out each of the each of the first three terms? Yeah, first three terms, okay? But first of all, before we do that, let's sub in theta equals pi over 6, okay? So sine of pi over 6 is just a half. So that means it's just going to be 1/12. So hopefully this makes it a little bit easier to work with, because now the sum of our first three terms is a 12th plus root 6 over 12 plus 6 over 12, which is 7 plus root 6 over 12. Okay, so that's our question 13 done. All right, so let's move on to question 14 now. Sorry again about the cut between. Okay, so you've got some differential equations here. So we've got the concentration of a lake is being monitored, and it's in milligrams per liter, and T as after modeling began, and we've got this equation here, okay? So A is a positive constant. Okay, particular solution. So that's actually, I heard a lot of things about this, why is it saying the word particular solution? Because actually that's used a lot in further, actually, in one of the chapters. So I think people got thrown off a little bit by this, but let's work through this anyways, okay? So dx by dt is equal to x a minus t. Okay, so what we're going to do is we're going to divide by x. So we get 1 over x dx by dt is equal to a minus t. And what we're going to do is we're going to integrate with respect to t on both sides. So that gives us 1 over x dx equals a minus t dt. All right, so if we do that, we're going to get ln of x equals at minus t squared over 2 plus c. Okay, now what we can do is we can raise both sides to the power of e. So we get x equals e to the at minus t squared over 2 plus c. Let's look at what the first piece of information it gives us. Initially, x equals 0.3. So t equals 0, x equals 0.3, right? So what that means is 0.3 equals e to the c. So c is equal to ln 0.3. Okay. Next, what can we do? We have x equals 21 when t is equal to 4. But before we do that, I want to do a little bit of simplification. So x equals e to the at minus t squared over 2 times by e to the c. So you can see all I've done is simplify it. So I've just brought it down, okay, because that's literally the same thing. But let me sub in that value of c. So as I think I said it earlier in this paper as well, e to the ln of any value is just going to be that value itself because it's an inverse function. So that means I can write this as x equals 3 over 10 e to the at minus t squared over 2. So now let's sub in t equals 4, x equals 21. So 21 equals 3 over 10 e 4a minus 8. Okay, so that is, if we multiply by 10 over 3, that gives us 70 equals e to the 4a minus 8. So 4a minus 8 equals ln of 70. So a is ln of 70 plus 8 over 4. Okay, so that gives us ln 70 plus 8 divided by 4. So roughly 3.06. Okay, I'm not sure if we should leave this in exact form or not because it doesn't say anything. But even though it's a bit messy, I'm going to suggest, I would suggest putting it as a decimal and then storing it in your calculator for future use. Or you don't even have to because we have the exact form. So I'm going to write it and then I'm going to state with a given to 3 significant figures. So let me write it out. X equals 0.3 e to the 3.06 t minus t squared over 2. And this is, so a equals 3.06 to 3 SF. Okay, so I've just written that there. So I've used 3.06 to 3 significant figures. Okay, I hope that is fine. Now we can move on to part B. So use a model to answer parts B and C, and C. So find the three significant figures the maximum concentration of the chemical in the lake. Okay, when we see the word maximum, we should be thinking of derivative. Okay, so let us do that. So we're going to take the derivative of this function here. So dx by dt is equal to, I'm gonna still write down 3.06, but you should know that I intend to use the stored value. So 3.06 minus 2t over 2, which is just t. And then we're going to multiply that by 0.3 e to the 3.06 t minus t squared over 2. Okay. Now what we want to do is we want to set this equal to 0. Okay. What we know is 3.06 minus t is times 0.3 e 3.06 t minus t squared over 2 is equal to 0. Well, what's really important to note is that this function here cannot be equal to 0. Okay, because it's a function of e, we should know that e never crosses the it never hits this axis here, the x-axis. So we can say that it's never going to be equal to 0. Okay, so what we can say is that requires t to be 3.06. T minus t squared, but as this function cannot be equal to 0. Okay, so what we can say then is, we can say that at 3.06, okay, so this is our stored value, by the way, let's remember that. What is our value of x? So what we're gonna substitute this value into our equation. Okay, so x equals 0.3 e 3.06 squared minus 3.06 squared over 2, and I'm going to use that stored answer. So 0.3 e to the alpha squared minus not alpha, a squared minus a squared over 2. So that gives me an answer of 32.600 and so on, which is 32.6 milligrams per liter to 3 SF. Because I believe that's what it asked in terms of. It was milligrams per liter. Yes. So that is part B done. Now part C. Find the time at which the concentration is 0.1 milligrams per liter. Okay. So now we're just pretty much doing the opposite. We know that x is equal to 0.1. So we can say, well, 0.1 equals 0.3 e to the 3.06 t minus t squared over 2. Let's divide by 0.3. Okay, so we should get 1 over 3 is equal to e to the 3.06 t minus t squared over 2. Now what we're going to do is we're going to do the ln. We're going to take the natural logarithm of both sides. Okay, so that gives us ln of a third equals 3.06 t minus t squared over 2. So this is 3 marks. So we've got a quadratic here, and it's fair to say we can put this in our calculator because it's going to be, the first thing I'm going to do is I'm going to shift this across here. So plus the ln of a third equals 0. Okay, now again, I'm going to put this in my calculator, but remember, I'm going to use my stored value to solve it. So I'm going to put a half, and then I'm going to put minus a, and then ln of a third. Okay, that gives me 2 possible values here. So it gives me that either t is equal to 6.464 or t is equal to minus 0.3399. But what is t measuring? T is measuring the time. Okay, so that means that we cannot, I don't know why I didn't say anything. T cannot be negative because it's a time. So as t is positive, it must mean that t equals 6.46 hours to 3 SF. Okay? Okay, so now let's start on the final question of the paper. So I heard a lot of people that were struggling with this question, this proof question, so I'm going to try my best to explain this, okay? So you can see here that the student is attempting to answer this following question. So they're trying to prove that a squared plus b squared equals c squared for a, b, c part of z. So I think this might be where some people might have gotten tripped up. So actually what this means is this z represents a set of all integers. So it's saying that this is only, we're trying to prove that a squared plus b squared equals c squared only works for integers. Okay, so it's saying that that's essentially what the notation is saying. So it started with a proof, so a equals 2n plus 1 and b equals 2n minus 1. B equals 2n plus 1. Okay, so we have to try and complete this proof. So why don't we just start off by going back and subbing it into the equation a squared plus b squared equals c squared. So 2n plus 1 whole squared plus 2n plus 1 whole squared equals c squared. So c squared equals 4m squared plus 4m plus 1 plus 4n squared plus 4n plus 1. So c squared equals 4m squared plus 4n squared plus 4m plus 4n plus 2. So let's see here. We can clearly factorize out 4 here. N squared, sorry, that should be n squared plus m plus n plus 2. Okay, we can see we can factor out 4 there. So what we can see here is that c squared is clearly even because we've got this even here, and if we add 2 onto an even number, it's going to be an even number. Okay, so c squared is clearly even. Okay, so c must also be even. So if c is even, we know we can represent that as 2k, where k is an integer. Okay. So if c is equal to 2k, well, what does that mean? C squared is equal to 4k squared. So we've just shown, so we know that c is even, okay? And we know, so any even value can be written as 2 times k, where k is an integer, for example, okay? So what does that mean? That means that c squared is equal to 4k squared. However, we have to look here. We have to compare these two, okay? This box here is saying that c squared is perfectly divisible by 4. So no matter what, you'll get no remainder. However, we can see here that c squared clearly has a remainder when divided by 4. It has a remainder of 2. Okay? So we can say, however, c squared is not actually divisible by 4. There is a remainder of 2. Okay? So there's a remainder of 2, which is a contradiction. Because we said that we've assumed that c, we have to prove that for integers. Okay? So we've clearly got a contradiction. So we can conclude by saying for a squared plus b squared equals c squared to be true for a, b, c. I can't really do that well. So for this to be true for a, b, c as a set of all natural integers, a and b cannot both be odd. So that is how you should conclude the question. So we've now completed the 2026 Edexcel A-Level Neuro Paper 1. And I hope this really broke down some of the concepts that people were struggling with when they sat this paper yesterday. And hopefully it allows you to at least see where you maybe can work on for your next paper. Okay, so don't get too hung up on the first paper. You can always make up for it in the next 2. Okay, there's 3 papers in total, don't forget that. So work on where you think you could possibly were weaker on. And, try and think about what topic based on this paper. And just try your best. And any other questions you might need, anything you might need help with, feel free to email me or leave a comment. Anything in this video, maybe that didn't make sense, or if you want me to work on something else as well, do the same. And I'm going to try my best to help as many of you as possible with these videos. And good luck with your next paper, and I'll see you in the next video.